For our final project, we're using multiple accelerometers through NRF24 wireless modules. The accelerometers and gyros we were using were the MPU 6050s. The main goal of our project was to interface multiple MPU 6050 chips using I2C protocol. These MPU 6050s would collect accelerometer and gyro data and send that data through an NRF24 chip. Then another NRF24 chip would collect that data and then display the accelerometer and gyro data onto a terminal. This is the schematic for our transmitter setup. Our transmitter setup includes an ATmega 328P AVR that is then connected to an NRF24L01 Plus, which is our wireless module that is connected through SPI. Then our MPU 6050s, accelerometer and gyro data, then is then connected through I2C protocol through PC4 and PC5. This is our schematics for our receiver setup. Our receiver setup only includes the ATmega 328P AVR and the NRF24L01 Plus wireless module. The wireless module collects the data sent from the transmitter setup, then the ATmega 328 sends the data through USART using a micro USB to the screen onto a terminal. The components we used for this assignment was two AVR ATmega 328Ps, 2 to 3 MPU 6050s, and then two NRF24L01 Plus wireless modules. The interfaces were the MPU 6050s. We're using I2C protocol. Since we're using that, the first address was 68 and the second one was 69, as you can see here. The NRF24L01 was just using SPI protocol. And then to display the data onto a terminal, we're using USART. The steps we took for the code development, the first one we did was initializing a timer for sending and receiving the data. The next thing we did was initialize the I2C. After that, we would initialize the USART for displaying to the terminal. Then we'd initialize the MPU 6050 registers, calibrate the gyro so that it gets reset every time it collects data. Then at that point, we would start the main code. As for the data collection for the MPU 6050s, the steps we took were getting the raw data from the MPU 6050, which that's the accelerometer and the gyro data. Then we'd convert that to the integers we would want. We are having like 8-bit integers. We would then convert those integers to characters, which would be then sent through the NRF24, so that when the other NRF24 received the data, it could just display it to a terminal instead of having to convert it there. At that point, we would recalibrate the MPU 6050s and restart this process. For receiving the data, it's pretty simple. So we would collect the data that was sent over from the transmitter setup. We would format our USART so that it prints, so we know what's being printed. After that, we would just display the accelerometer and gyro values to the terminal. Since the data we were collecting would have a lot of noise to it, we were to use Kalman filtering to filter out that noise to get smooth values. As you can see, the equations are over here. We were to do this in our transmitter code. We'd get the code, do all the equations, and then the output from those equations are what we sent over to be received and then displayed onto a terminal. To show some visualization of the data that we are getting, we have some graphs here to show. Over here you can see the X, Y, and Z axes. Here is X, Y, and Z. X and Y are both really close to 0. YZ is a lot more. That is because the way the accelerometer is. You can see in the pictures of our terminals that we took, whenever we had values that were relatively close to 0, there's always be one that would be a lot more, which our values were usually close to 16,000 or negative 16,000. Over here you can see it being turned to the side, and down here you can see it being turned to the other side, so the Y and X values are a lot more. Over here we have the same values and ideas as over here, but in graph form. So right here is pretty much the same as here. As you can see, it's hard to see, but the Z value is up here, and the X and Y values are down here. With here, it's over here, so you can see the Y value is a lot higher, and the X and Z value are down over here. Same with here and over here. I like these graphs because it shows the transition of me turning the accelerometer over, so you can see that the values changing rapidly. As you can see, there's a decent amount of noise. That's where the Kalman filtering will come in and would hopefully smoothen that out. For the final submission, The links will be added to the PowerPoint of this, but in this video they have not been added yet. All these next two slides show is that me and my partner were working on this project together. It shows what each of us did and how much we contributed towards the project. For the most part, we pretty much worked on it together, usually at the same time, so we would be working on the same stuff. So not much would be difference between him and I working on it. This is what my partner completed. Since we were working on this together at the same time, it's pretty much the same as what I completed. So as you can see, there's a little difference, but pretty much the same as what I had.